reliable. So solving systems of linear equations. Okay, so this unit was when we were given two different linear equations. We had to graph two lines. And when we graphed the two lines, maybe one line did this and the other line did this. The place where they crossed is our answer. The place where they cross or intersect is the answer. So whenever we are solving for any of these using substitution or elimination, we're solving, what we're getting is that point where those two lines cross. So my word problem that I'm going to go over with us is there are twice as many girls in the class as boys. There are 42 students total. Set up a system. And solve for number of boys and number of girls. Okay, so that is our word problem for this situation. When we are given a word problem, the first thing that we want to do is to write out our two equations. In order to do that, we need to identify our variables. So if I'm solving for my number of boys and my number of girls, those are the variables that I'm looking for. So number of boys is going to be represented by B, and number of girls is G. It's really, really important that you are very clear what your variables stand for. So in this one, it doesn't matter so much, but say we were dealing with money and number of something, you need to be really clear that if X is equal to coins, do you mean cost of coins or number of coins? So that's why we write out number of boys and number of girls, not just boys and girls, even though this question, it's more straightforward. Does that make sense? Okay. Now we can write our equations. So we're going to use the information in the question, and we're going to start by reading that first sentence. So the first sentence says there are twice as many girls in the class as boys. So I'm going to write that out. 2G equals B. Is that correct? Are you sure? Read the words again. There are twice as many girls in the class as boys. No, why is it incorrect? What should it be? G equals 2B. Yes, thank you for catching my mistake.
You did it on purpose.
Yeah, I know. G equals 2B. So the reason the other one was wrong and this one is right is because in this situation, if I throw in random number for B, if I go 2 times 5, I have 5 boys, but that's going to equal 10 girls, okay? So G equals 10. If I did it the other way, there would be less girls than boys. And so we just need to be careful that it makes sense. If you're unsure, test it with a small number first. See if it just logically fits what you are reading. That's okay to do as well. So that's my first equation. My second equation, so that second sentence, there are 42 students in the class total. Or 42 students total. What would this equation look like? It's something equals 42, but what equals 42? Pardon? Are you sure it's G times B? Plus B, yes. Okay, we're not multiplying the boys and girls together. We don't do that at school. We are going to add them to get a total of 42. Okay? Now we've set up our two equations. We have two equations we can actually solve for a system. We have two different methods that we can use, okay? These are important that we know the difference, and we can do both. So, one is called elimination, and one is called substitution. For the method of elimination, I'm going to make both equations equal to 0 and line them up, one on top of the other. So, G equals 2B becomes G minus 2B equals 0. The G plus B equals 42 becomes G plus B minus 42 equals 0. And just to make this a little bit clearer, I'm going to move that 0 over here. Okay, so I've lined them up one on top of the other. My G's are in line, my B's are in line, and there's no constant for this first equation here, so I've left that spot blank. Okay, you could also write this one below, it doesn't matter. So that might look a little nicer for you. Now I'm going to look at this and I'm going to go, okay, I've got two options. I can either do addition or subtraction, but I need to make sure I get rid of one of my variables. So I either want to get rid of the G or get rid of the B. Okay, because I can only solve for one variable at a time. So which variable do you think I should get rid of for this one? G or B? Yeah, so I'm going to subtract G, because if I go G minus G, that's going to cancel each other out. And then I'm going to be left with B minus 2B, which is just B. Okay. Sorry, negative B. Minus 42 equals 0. Oh, sorry, that's negative 3B. That's my fault. Or 3B. Sorry. I was looking at that, I'm like, that's not right. Okay, now I'm going to solve for B. So I'm going to add 42 to both sides. I'm going to be 3B equals 42. This might give me a decimal because I didn't actually plan the numbers. I just wrote numbers down. B equals 42 divided by 3. Someone tell me what that is. Use a calculator. Does not give me a decimal. I was lucky. We don't have any portions of kids in this class. 14. Okay, so B equals 14. So there are 14 boys in this class. Now I'm going to plug the B back into one of my original formulas to solve for girls. It does not matter which one you choose. I'm going to put it into this first one here. So G equals 2 times 14. So 2 times 14 is 28. There are 28 girls in the class. So the number of girls equals 28, and the number of boys equals 14. Now you can double check this just by adding them together and making sure that it equals our total. It does. So that is our final answer using the method of elimination. Okay, in the method of elimination, if none of your variables are the same, so say that this was 2g and 2b, just for example, okay, it's not actually that. You would need to multiply by this whole top term by something that would be able to get equivalent values. So in this case, it would be nice and easy. You would multiply each term by 2, but sometimes it might be 3, 5, whatever it is, in order to get two things that will cancel each other out. Okay? Questions about that? Awesome. So let's talk about substitution. So I'm going to use the same equations that I did before. So g equals 2b and g plus b equals 42. So those are my two equations for substitution. What I'm going to do is replace or substitute one of the variables with an equation so that I only have one variable left over. So I'm going to look at this one and I'm going to say, okay, g is already by itself on this equation. Nothing else is on that side. So I know that whenever I see a g, it's going to equal 2b. So I can replace the g in this equation with 2b. Because I know that g is equal to 2b. So they're the same thing. So then I would have 2b plus b equals 42. Well, 2b plus b is just 3b equals 42. And then I would divide both sides by 3. B is equal to 14. And that is just the method of substitution. That's all it is. So you see we got the same answer both times. We even got the same equation partway through, which doesn't always happen, but in this case it did. But that's how we would solve using either method. Most of the time, it doesn't matter which one you use. Okay? Sometimes it's easier to use substitution if you don't have any variables that have the same amount. Okay, so in this case, both equations had 1g, but if one had a